questions 11 through 20 of the 2002 Grade 12 AMC 12A. Mr. Earl E. Bird leaves his house for work at exactly 8 a.m. every morning. When he averages 40 miles per hour, he arrives at his workplace 3 minutes late. When he averages 60 miles per hour, he arrives 3 minutes early. At what average speed in miles per hour should Mr. Bird drive to arrive at his workplace precisely on time? So the main equation in this question will be speed is distance over time. And they give you two scenarios. The first scenario is that the distance over 40 miles per hour is equal to x plus 3. And what they've done is really just flip these formulas. So we're doing time is equal to distance over speed. All right, x plus 3 because he's 3 minutes late. X being the time that is exactly when he should arrive at work. The second scenario is the same distance, but this time the speed is 60, and he's arriving 3 minutes early, so x minus 3. And what we want to figure out in our question is the speed for which the distance is d. Well, the distance is always d, but when the time is equal to x, when he arrives precisely on time. Because remember, we are putting x to represent that. So hopefully we can get d over x by some manipulation of these two, this one and this one. Well, let's add them and see what happens. X plus 3 plus x minus 3 is equal to d over 40 plus d over 60. And this becomes 2x because the 3's cancel. And then we're going to have to put a common denominator, d over 40 plus d over 60, 40 over 40, like that. So we got 60d plus 40d over 60 times 40 is equal to 2x. And let's see, this becomes 2x is equal to 100d over 2,400, correct? And therefore 2 times 2,400 is equal to 100d over x. So we have 4,800 is equal to 100d over x. And then divide both sides by 100, and you'll get 48 is equal to d over x. And that's exactly what we want. D over x is equal to 48, and that represents a speed. So his speed is 48 miles per hour when he arrives at work precisely on time. So number 11, the answer is B. Both of the roots of the quadratic equation, x squared minus 63x plus k is equal to 0, are prime numbers. The number of possible values of k is. So we've got x squared minus 63x plus k is equal to 0. And let's say it has two roots. Well, that's what the question says, both roots. We'll call them R1 and R2. So that basically means that x minus R1 times x minus R2 is equal to 0, right? That's a way of representing the equation if you know the roots. Well, we can set these equal to each other. X squared minus 63x plus k is equal to x minus R1 times x minus R2, like that. The left side we'll leave alone for now, and I'll expand the right side. So we have x squared minus r2x minus xr1 plus r1 r2, like that. So if we rearrange this to make it match the left side, it will be x squared plus minus R2 minus R1 x plus R1 R2. All right? So that means that these coefficients must match. So that means that minus 63 is equal to R2 minus R1 minus R2 minus R1, and K is equal to R1 times R2. Okay? But remember, both of the roots are prime numbers. So I'll write that in here. Both R1 and R2 are prime numbers. Now this first one here, if you get rid of the negatives, it'll be just R1 plus R2. And this one is fine the way it is. So we have to find two prime numbers that when added equals 63. Is that possible? Well, 2 and 61 would do it. 2 is a prime, 61 is a prime, and 2 plus 61 is 63. And therefore K would be equal to 2 times 61, which is 122. So we have one possible value for K. Can we find any more? Well, 63 is a prime number, or no, 63 is not a prime number. 63 can be divided by 3. So it's not a prime number, it's just a number. But one thing for sure, I'm positive of this fact, that 63 is odd. And if you have two numbers, any two numbers, and you add them together, and you want to get an odd number, one has to be even, right? One has to be even, and the other one has to be odd, like that. That's the only way you can get an odd number. If you have two odd numbers, odd plus odd, like that, the result is always going to be even. You can try it, right? 9 plus 9, whatever, 13 plus 17, that kind of thing. And every prime number is odd. So if you have two prime numbers, they're always going to be odd and odd. So you're never going to get an even result. The only exception is 2. 2 is the only prime number that is even. So this odd plus even combination can only happen when one of the numbers is 2. So that's it. This is the only possible choice or calculation for K. So only one. So the number of possible values of K, there's only one, so 12 is B. Two different positive numbers, A and B, each differ from their reciprocals by 1. What is A plus B? Okay, so A, if that's the number, it differs from its reciprocal by 1, like that. And B differs from its reciprocal by 1 also. But this is exactly the same. There's no difference here. So this scenario would not give you two different positive numbers. It would give you the same if I were to eventually calculate this. So they don't actually tell you how to do the subtraction. They just tell you they differ. So that means I could do it like this. I could say 1 over B minus B is equal to 1. You see what I mean? So this is a little bit of a interesting question. So let's work with what we have and try to calculate. So the first one, you get a common denominator. It'll be A squared, or just multiply through by A, and you'll get minus 1 is equal to A. Put everything on one side. A squared minus A minus 1 is equal to 0. And unfortunately, this doesn't factor, so I have to use a quadratic. That's fine. Minus B plus or minus square root of B squared minus 4AC all over 2A. So we got 1 plus or minus 1 plus 4, so that's root 5 all over 2. So I got two possibilities, but one of these is a negative number, and they tell you that they're both positive. So the 1 minus root 5, that one we can't use. So we have to use 1 plus root 5 over 2. Okay, so I got A. Now in a very similar way, let's calculate b. Multiply through by b, and you'll get 1 minus b squared is equal to b. Put everything on one side, you get b squared plus b minus 1 is equal to 0. Use a quadratic. We got minus b plus or minus the square root of b squared minus 4ac all over 2a. Okay? So this becomes negative 1 plus or minus 1 plus 4. So we got root 5 again, and over 2. And very similarly, the 1 minus root 5 we can't use because a and b are positive. So the only one we can use is 1 plus root 5. So that's b. And therefore, they want us to find a plus b, correct? What is a plus b? Well, I'll do it up here. A plus b. A is 1 plus root 5 over 2. B is negative 1 plus root 5 over 2. So this looks like 1 minus 1 is 0. Root 5 plus root 5 is 2 root 5 over 2, which just becomes root 5. So there you have it. 13, the answer is C. For all positive integers n, let f at n equal log of 2002 n squared. Let n equal f at 11 plus f at 13 plus f at 14. Which of the following relations is true? So f at n is equal to log of n squared to the base 2002, and n is equal to f at 11 plus f at 13 plus f at 14. So plug 11 into this, and that will give you the log of 11 squared to the base 2002. Very similarly, f at 13 becomes log of 13 squared to the base 2002, and f at 14 becomes log of 14 squared to the base 2002. And then we know that there's a rule that if you got this exponent out there, it just comes in front like that. So that definitely helps out. Log 13 2002 as the base plus 2 log 14 to the base 2002. Okay? Now let's see, we can factor out a 2, and that will just give you log 11 to the base 2002 plus log 13 to the base 2002 plus log of 14 to the base 2002. And then there's a rule that if the bases are the same and you're adding like that, you can write it in the following way. It will be just 11 times 13 times 14, like that. Okay? So this becomes log of 11 times 13 times 14 is 2002 to the base 2002. And we know this part, I hope you know, is equal to 1. So there you have it. This whole thing, n, is equal to 2. N equals 2. So which of the following relations is true? This one, n is equal to 2. So 14, the answer is D. Number 15 and number 16 I will do in a few seconds, but the numbers are numbered differently, but they're the exact same questions, so don't get confused. Questions 21 through 25 of the 2002 grade 10 AMC 10A. The mean, median, unique mode, and range of a collection of 8 integers are all equal to 8. The largest integer that can be an element of this collection is. So I'll let my integers be A, B, C, D, E, F, G, H. And the first thing is, let's understand this question. Mean, median, mode, and range. So 4 things are all equal to 8. Okay? So let's start with the median. If the median is 8, this is an even number, so that means that these two have to both be 8. That's the only way we can get the median to be 8, because the average of those two numbers is going to be 8. So that takes care of the median. Now let's take a look at the mode. Well, the mode is also 8, but we don't know how many 8s there are. There's obviously at least 2. And therefore, we don't know how many, so the only thing we can do is just list it as 8. But how about the mean? The mean is something that I hope will help us. A plus B plus C, all the way up to G, all the way up to H actually, is equal to, if you take the mean, 8, like that. So the sum of A plus B plus C plus D, like that, will be equal to 64 rather, like that. So we know based on our labeling that D and E are 8, right? This one is 8 and that is 8. So I can take those out and just sort of look at the other letters, the other integers. So if I take out 8 and 8, this sum will be left with is 48. Okay? And at this point, we have to experiment. So the next thing I'm going to look at is the range. Don't forget about the range. Your mean, median, mode obviously are part of it, but the range is also part of it. What do they mean by that, first of all? Range. They mean that if you take the largest number, h, we've listed this from smallest to largest, and the smallest number, h minus a is equal to 8. That's the range. Okay? So let's now see what we can find. This is all trial and error at this point. So let's move this up. So if we have, let's say, 8 for A. Remember, we can't go higher than 8, because if we go higher than 8 for A, then this is no longer going to be the median. Like if we make A equal to 9, then D and E are no longer the median, right? 9 is now going to mess all this up. So the highest we can go for A is 8. So let's see what we get. If A is 8, H has to be, look up here, has to be 8 more, right? So it has to be 16. So therefore, B plus C plus F plus G has to be 48 minus 8 minus 16, which is 24. So can we get 4 of these equal to 24 and maintain this order up here? And let's see. If you have 4 numbers that add up to 24, each of them, at least one, has to be less than or equal to 6. All right? But that's not going to work because we have our smallest one set as 8. So we can't have another one less than or equal to 6. So that's no good. Okay, no problem. Just keep going. Let's try for this scenario here, up here. Let's try 7 for A, and therefore H would be 8 more than that, which is 15. All right? If we do that, our remaining integers will be equal to 48 minus 7 minus 5, which is 26. How about here? If we have 4 integers add up to 26, at least one is going to be less than or equal to 6.5, but 6.5 is not an integer, so it's got to be 6. So it's the same scenario. We can't have that, right? Because we set our lowest or smallest integer to 7. So that doesn't work. Let's keep going. Let's set A equal to 6. If A is 6, then H will be 14, right? Because it's 8 more. And therefore, the remaining integers have to add up to 48 minus 6 minus 14, which is 28. Now, can this work? If you have 4 integers that add up to 28, then at least one has to be less than or equal to 7. And yeah, that'll work. So now we have to figure out what A, B, C, and D are. A, B, C, D, E, F, G, H, right? So we've got 6 and 14. From up top, remember we had 8 and 8 for D and E. So 8 and 8. And then we want all these guys add up to 28. So how can we do that without messing this up? Well, if we make 2 of these 8s and then 2 of these 6s, that will work. This will be able to all work out. Because remember, we can't go lower than 6 for B and C. And if we made them 7s, then if we made them 7s like that, then these will also be 7s, but that would mess up the entire order. These would no longer be the middle numbers. So the only way to make all the conditions work is with 6, 6, 6, 8, 8, 8, 14. And the largest, therefore, is 14. And that's what they wanted you to figure out, which is choice D. Tina randomly selects 2 distinct numbers from the set 1, 2, 3, 4, 5, and Sergio randomly selects a number from the set 1, 2, all the way up to 10. The probability that Sergio's number is larger than the sum of the 2 numbers chosen by Tina is... All right, Tina chooses 2 numbers, and Sergio chooses 1 number. Tina has to choose 2 distinct numbers, so the first number, she has 5 possible choices. But the second number has to be one of the other 4. She can't select the same one because the 2 numbers have to be distinct. So for the second number, she's got 4 choices. Sergio only has to select a number, so only 1, from the set 1, 2, all the way up to 10. So he's got 10 choices. So the total number of possible selections, I guess, for both of them is 5 times 4 times 10, which is 20 times 10, which is 200. All right? Now, of those 200 possible variations, how many are such that Sergio's number is larger than the sum of the 2 numbers chosen by Tina? All right, so first let's figure out very quickly, we can do this, Tina's situation here. If she chooses 1 and 2, what is the sum? It'll be 3. Similarly, if she chooses 1 and 3, the sum will be 4. S for sum. 1 and 4, the sum will be 5. And if she chooses 1 and 5, the sum will be 6. All right? So we can make a very quick table here. Similarly, 2, 1, 2, 3, these are her 2 numbers. And the sums will be 3, 5, 6, and 7. All right? And then 3, 1, 3, 2, 3, 4, and 3, 5. The sums here are 4, 5, 6, and 8. And I think we have just a few more. 4, 1, 4, 2, 4, 3, and 4, 5. The sums here are 5, 6, 7, and 9. And finally, 5, 1, 5, 2, 5, 3, and 5, 4. And the sums here are 6, 7, 8, and 9. Okay? So this is our table. Now, Sergio is going to select a number from 1 to 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. These are his selections. What we have to figure out is that for each of these, how many of up there are smaller because his one number has to be greater than the sum. All right, so let's see. If Sergio's number is 1, can that be greater than any of the sums? No, so 0. 0 possibilities there. If Sergio's number is 2, can that be greater than any of the sums? No, because the lowest sum is 3. So again, 0. If Sergio's number is 3, can that be greater, right? Remember, larger, not equal, larger. Can it be greater than any of the sums? And the answer is no again, 0. But once we get to 4, the answer is yes. This one. We have 2 possibilities. When Sergio chooses a 4, what was her name? Sorry, Tina. I forgot her name. If Tina has a 1 and 2, that will be a sum of 3, and therefore 4 will be greater than 3. If Tina selects 2 and 1, she will have a sum of 3, and 4 is greater than 3. So there's 2 possible ways that can work. And similarly, we got to figure this whole thing out. So 5, let's see, if the sum has to be 4 or less, right? So we've got this one, and this one. So we got 4 of those. 6, the sum has to be 5 or less. So 1, 2, 3, 4, 5, 6, 7, 8. For 7, the sum for Tina has to be 6 or less. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Sorry, this was a 7 in there. And don't make these little mistakes like that. That would cost you the question. All right, no problem. So how many did we underline? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right. If Sergio selects an 8, the sum has to be 7 or less. So that looks like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 9, sum has to be 8 or less, and that's 18. And then sum has to be 9 or less if Sergio selects 10, and that's all of them. All right? So as long as you didn't mess up on the math like I did, then you'll be able to get the right answer. So how many selections are possible? Well, you got to add all these up, right? So you got 2 plus 4 plus 8 plus 12 plus 16 plus 18 plus 20. These are the ones that satisfy our criteria. And the total, remember, was 200. How many total scenarios, total variations? So this is the probability. We just got to do the math now. The numerator is 80. The denominator is 200. And this reduces to 8 over 20, 4 over 10, or 2 over 5. All right? So 2 over 5 is choice A. Several sets of prime numbers, such as 7, 83, 421, and 659, use each of the 9 non-zero digits exactly once. What is the smallest possible sum such a set of primes could have? So what do they mean by this? They basically means that you have this set, and all 4 of these numbers is prime. And to create these numbers, they used all the numbers from 1 to 9. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9. And they're saying, create another set like this, but a set that has the smallest possible sum if you were to add up the numbers. All right, this is going to be a trial and error type of scenario. And it's one of those questions that tells you that you have to sort of memorize all the prime numbers. At least, to be honest, the first from 1 to like 100, all the prime numbers in that range. So let's list them and see what we get. We got 2, 3, 5, 7, 11, 13, 17, 19. 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89, and 97. Okay, these are all the primes less than 100. So in a trial and error way, we have to find a set. It doesn't necessarily have to be 4. They don't really say it has to be 4. That's actually something I need to point out. It just has to be a set where all the digits from 1 to 9 are used when you made these prime numbers. Okay, well, let's just go with this here. So first I've got to use all the digits from 1 to 9, right? So let me write them out. That way I can circle them as I use them. Okay, so we've got 2 here. So let's use that one. We got 2. I'm making a set here. So I'm going to write my set brackets. Now let's use 3. Might as well. Let's use 5. So far I've used 2, 3, and 5 as the digits. Oh boy, how do I proceed here without messing up? If I use 7, there you go, then I can't use 11 because that will use the 2-digit ones, and I can't do that. I can only use 1 once. 13 I can't use because I've always used up to 3. 17 I can't use because I've already used the 7. Can I use 19? I think so. So that uses 1 and 9. 23 I can't use because I've already used the 2. And similarly 29. Can't use 31, 37 because I've already used up to 3. 41 I can't use because I've already used up to 1. 43, same reason. 47. So I can't ever get a 4 in there unless I go beyond 97. So that's fine. We can try again. Now I'm going to start, but this time I have a different approach. One thing I noticed is that when you start making these primes, right, or using them, it's going to be very difficult to get the even numbers. So you notice how I got stuck with the 4 scenario? I got to 4 and I was basically finished. So I'm going to start using the even digits here first. See what I mean? So I'm going to start using 4 and 6 and 8. So here we go again. Let's use the 2 because that's an even number. Let's concentrate on the evens. So I've got 2. All right, I've got my first of the set. Now let's calculate another prime using an even digit. 4 is an even digit. So which one do I want to use? 41, 43, or 47? Well, I don't know. So let's start with 41. Let's keep that. And then 6 is the even one. It's hard to get rid of the evens, so I'm concentrating on them first. How about with 6? We've got 61 and 67 as choices. And I can't choose 61 because I chose 41. So the 1 has already been taken. So by process of elimination, I have to choose 67. And then I'm going to go with the next even number, which is 8. And 8, I've got 83 and 89. Ooh, I've got 2 choices here. If I choose 83, then the 9 will be by itself. But if I choose 89, then the 3 can be opened up as an individual prime. See what I mean? So I'll choose the 89, and then the 3 actually I can now choose as its own prime right there. So let's circle what we've chosen so far, 67 and 89. And what do we have left? 5 and 7. 5 and 7. Well, 7 actually I already chose with this with the 67, and 5 is a prime by itself. All right, so I did it. A little bit of trial and error. So I got 2, which is a prime, 3, which is a prime, 5, 41, which is a prime, 67, and 89. So I created a set of primes that use all the digits from 1 to 9. Now I got to find their sum. So 2 plus 3 plus 5 plus 41 plus 67 plus 89. And this sum is 207. Okay? And that, let's see if that's one of the answer choices. It is. 207 is B. And I encourage you to fiddle around with these kinds of questions. It's really just trial and error. And I hope that with practice you'll be able to do this quicker and quicker as time goes on, because on math contests, as you know, you don't get much time. Question 18. Let C1 and C2 be circles defined by those two equations respectively. What is the length of the shortest line segment PQ that is tangent to C1 at P and to C2 at Q? Okay, let's draw a graph and explain this question. So I'm going to draw a graph like that. And first, I'm going to label the points. Actually, I'll just draw the circles first. So the first circle, this is what these are. I hope you can identify that, because the equation of a circle is of the form x minus h squared plus y minus k squared is equal to r squared, where hk is the center and r is the radius. Not r squared, but r. So here is a graph that best represents, I think, this question. And let's explain what's going on. So the first equation is a circle with center 10, 0, and this is C1. So I wrote that here. And therefore, if this is the center, and the radius is equal to 6, right? Because this is r squared. And then C2 is over here, and this is a circle with center minus 15, 0. So right here, approximately there. And this radius is 9. Okay? So the first thing I have to do is I've got to draw some lines to represent the radius of this circle. So I'll draw a line from the center to the tangent point right there. And that tangent point, they tell you in the question for C2 is Q. So that's Q right there. And the tangent point here, I'll draw a line, is from the center here to that tangent point. And that is P. And they want you to find the length of segment PQ, that line that is going to join P and Q, the length of that segment. All right, so what do we know about tangents? We know that the tangent point is a right angle right there. Those are right angles, okay? And what else do we know in this diagram? This is the x-axis, this is the y-axis. Not that that's going to help, but it's important to understand that. Well, let's start labeling this if we know any distances. The radius, of course, of C2 we know is 9, so this green line is 9. Over here on C1, the radius is 6, so this green line is 6. What else do we know? We know the center is minus 15, 0. So we know that from here to here is 15 in terms of a length. And similarly, we know this center is 10, 0. So the distance from the origin till that center point is 10. And yeah, I see two Pythagorean relationships here. The first one I see is, obviously, I'm sure you can see it too, this triangle. And therefore, I'll label From Q to the origin, I'll label it X. And then the second triangle that we will need to use is that one right there. And I'll label P to the origin as Y. Okay? And using that, we can calculate X and Y, and then we can calculate X plus Y, which is basically going to be the length of QP. So here we go. Our first big triangle, we'll have 9 squared plus X squared is equal to 15 squared. So that means X squared is equal to 225 minus 81. So X squared is equal to 144, and therefore X is 12. From our smaller circle and smaller triangle, we have Y squared plus 6 squared is equal to 10 squared, and therefore Y squared is equal to 100 minus 36. So Y squared is equal to 64, so Y is equal to 8. And therefore, since QP is equal to X plus Y, that would mean 12 plus 8, and that is 20. So QP is 20. It's the shortest possible distance also. So 18, the answer is C. The graph of the function f is shown below. How many solutions does f at x equals 6 have? So we have f at x is equal to 6, right? And we all know that y is equal to f at x. So this basically is saying, first, it's saying that we want to figure out when does this graph have y as 6. Okay? That is what this part is saying. For what values of x is y equal to 6? Well, the good news is that they've actually labeled those right there. Y is equal to 6 when x is either minus 2 or 1. So that basically means that f at negative 2 is equal to 6, and f at 1 is equal to 6 also. Okay? I hope that's clear. If it is clear, then we can proceed, concentrating on the fact that we now need to look at this guy right here and compare it to these numbers. Okay? So from the first one, we get f at x is equal to negative 2. And the second one, we get f at x is equal to 1. And we now have to figure out what are the values of x. Very similarly, when y is equal to minus 2, what are the values of x? Well, when y in this graph is minus 2, where is minus 2? It's right here, right? So x looks like it's here and it's here. So approximately 3.5 and minus 6 approximately. We don't really need to know the exact. They just wanted us to figure out how many solutions. And then now let's concentrate on this one. F at x is 1. So when y is 1, what is the value of x? Well, this is 1 right here on the y-axis. When y is 1, how many x's? Well, we got 1 here. It's approximately, what is that, about minus 4.5 approximately. And then we have another value here on the x-axis. When y is 1, that's about probably minus 0.5. Then, really difficult to draw, but right there we got another one, about positive 0.2. And then the last one is here, when y is 1, so that's about 2 point something, 2.7, let's say. So how many solutions did we get? We got 1, 2, 3, 4, 5, 6. 6 solutions. So the answer for number 19 is D. Suppose that A and B are digits, not both 9 and not both 0, and the repeating decimal 0.AB is expressed as a fraction in lowest terms. How many different denominators are possible? So you've got a number 0.AB repeat. So that basically means AB, 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 and so on. Okay? Dot, dot, dot. Just keeps on going like that. Anytime you have a number of that form, it can be written as a fraction like this, AB over 99. Now you say, well, how did you get that? Where did you get that from? Well, try it. Try any number. Take out your calculator, like for example, 272727, like that, right? 27 over 99. Put it in your calculator. You'll see that it will be this. So any number that repeats like that is basically AB over 99. Okay? So they want you to figure out how many different denominators are possible. Well, you might say, well, 99, that's the only one, isn't it? And 1 is not one of the choices, so obviously there's more. But how is there more? Because these fractions can be reduced to lowest terms. In this one, for example, that I gave, 27 over 99, if you divide top and bottom by 9, you'll get 3 over 11. So 11 becomes a possible denominator. You see what I mean? That's why there's more than one. Okay, so how do we proceed here? Well, look at the number 99 and break it down into its factors. 3, 3, and 11, right? That's basically what 99 is. 3 times 3 times 11. 9 times 11. So if you have a number like that, how many possible factors are there? Well, we've got 1 as always, 3, 9, which is 3 times 3, 11, 3 times 11, and the full number. These are the factors. So these are the possible denominators, 6 possible denominators. And one of them I gave you as an example, 11, it's right there. Now, there's a little bit of a trick here. I hope you can see that, because 6 is not one of the answers, which is a good thing, because otherwise people will just choose 6 and move on. So you might say, well, 6 is not one of the answers, so what's the story here? Because one of these is not allowed in this question. Which one is not allowed? There's something that in the question that you need to utilize right here. Not both 9. AB cannot be 9, 9. Okay? Because if it is 9, 9, watch what happens. This guy would become 9, 9 over 9, 9, which is equal to 1 over 1, basically. So since that is not allowed, the denominator of 1 is not allowed. So this guy is not allowed. So that leaves us with only 1, 2, 3, 4, 5 possible denominators. So therefore the answer to number 20 is C.